Hey, what's going on YouTube? Welcome to the 6th tutorial in our series Building a Render Engine in C++. Today I'd like to talk to you about something called frame buffers. Right now if we go into our rasterizer, you'll notice we are actually printing directly onto the screen here. Now, the big problem with this is, well, first of all, in normal render engines you won't actually have the option to print directly onto the screen for the most part. You can in some situations, but not in most. And it's really inefficient as well, because by doing this it means everything pretty much has to be done on one thread. It doesn't necessarily have to be done on one thread, but it can lead to things like flickering, it can lead to things like screen tearing, all things that we'd like to avoid. So today in this tutorial, what we're going to do is, instead of rendering directly onto the screen here, we're going to render onto a construct that simulates the screen. And then in a different thread we're going to print that thing to the screen. So this construct is just going to have a bunch of integers to represent everything about the screen that you need to know. Now you might be thinking to yourself, wait, that's super inefficient. Why would we ever do that? Well, the reason why it's completely fine is because you can actually utilize multi-threading with this very easily. And the way we're going to use it specifically for this tutorial is we are going to greatly improve the speed of this engine and make it really fast by rendering to one buffer at the same time as another one is being presented to the screen. The reason why that works is because actually presenting the frame buffer to the screen takes longer than rendering to the frame buffer itself. So anyways, let's go ahead and get started. First of all, let's go ahead and open up include/rasterizer.h, and in here what I'm going to do is actually delete this class or structure. So I'm going to delete that frame buffer here, and instead I'm going to include framebuffer.h, which we haven't yet made, but we will in a second. And the final change I'm going to do is fix a typo here. I called it get frame buffer with a capital B. Frame buffer is one word, so change that to a lowercase b to fit convention. That will be the only changes in this class, or that file actually. Go ahead and open up the make file now, and then go down to this line and then include framebuffer.h and then framebuffer.o, and then go ahead and exit that because that's all we're going to need. Go ahead and open up a new tab, framebuffer.cpp, and then tab new include/framebuffer.h. Alright, actually we want to do that. So in the h file, let's go ahead and add our include guards. And then create the class. And then we're going to need public members, and then we're also going to need private members. The private members we're going to want are going to be int width, int height, well, not int height, which we've established. Let's just go ahead and recreate the same frame buffer class we had before, but this time we're using a class, not a struct. So we're going to want just a normal constructor here. We don't need a copy constructor. We don't need an operator equals. Not going to need it. So int width equal, no need for default values. So then if we do that, and then we come over here and include framebuffer.h in this file, put this down, and then create our include list include list, initialization list, and pass in those values. So now we have that constructor here. Let's go back to this area in rasterizer.cpp, and you'll notice first of all we made these members private, so we're going to have to make some small changes to the way we receive that, because when we're doing this we're receiving fb-width or .width directly. So what we want is instead get width and then get height. And then if we come over here we actually have to create those methods. So inline int get width, const, I don't know what I'm doing, const return width, and then we can do the same thing, get height, and then return height. So with that out of the way, that is our main stuff. So let's go ahead and actually create a virtual destructor. And we're going to actually utilize this virtual constructor as well this time around, because normally in the past we just created them without actually using them. But we're going to need a few other things. We're actually going to need to create some new little type defs. So those type defs are going to be, we're going to need a type def uint 8t as the depth buffer t. And then we're going to need to type def a uint 16t pointer as the color buffer t. And the reason why we're doing this is because we're going to need an array of pixels. In each pixel there's going to be a depth component and there's going to be a color component. The color component actually needs 2 bytes of information. The first byte of information is going to be it's going to be in the lower bytes. That'll just be the character to print to the screen at that certain location. And then it's going to need the color of the pixel at that location as well. And what we'll do is we'll be able to create these types inside this class, and then just like this. So depth buffer t depth buffer, and then color buffer t color buffer. Let's go ahead and see if this compiles. It does not. uint8t does not name a type. Okay, so we have to, of course, include defs.h. So now it'll compile. Okay. So now that that's out of the way, we can go ahead and actually at the end here, we can delete color buffer and then delete depth buffer, and then those can go away. And actually I think it's a little bit confusing to include the pointer here because it almost looks like this is being named as an individual type, but really it's being named as a pointer type, so I would prefer to be a little more explicit and do that instead. I think that's the right way to do it in this case, just for design purposes and for consistency. So now let's go ahead and actually allow the depth buffer to be created. So we'll have void recreate, and this will take an int width, int height. And the reason we'll have this method is because we want the frame buffer to be able to be reinitialized at different size values. And just for kicks and giggles here, let's go ahead and call that recreate function with width and height here as well. So, and then well actually I don't even want this recreate function. Yeah, actually I do. It's fine. So you give it recreate, and I believe in this area we can go ahead and set and then so we just set that at the beginning, and color buffer equals new color buffer t, and then we give it the size of width times height, and then for the depth buffer as well, and it's going to be equal to a new depth buffer t width times height. Next thing that we're going to want is the ability to clear the frame buffer. So void, we don't need any arguments for this. And to clear, all we're going to do is come over here and then use a mem set. So up here include memory.h from the C library, so we have access to that, and then we can go ahead and do mem set with the colors, and then I'm actually going to pass in a int clear color as well, just to make it a bit better, and that way we don't have to create a member. So then memset color buffer, we want to set that to clear color, and then we want to pass in the size of the color buffer t times width times height. So size of color buffer t times width times height. And there we go. We do the same thing now for the depth buffer. And then, but instead we pass in the max value of the depth buffer. So max depth value, and we're going to have to define that, but depth buffer t is the final argument for the size of that times width times height. But now we need to go ahead and define max depth value, and this is just going to be 0xff, because the reason why that's going to be 0xff is because this is an 8-bit integer, and the max value of an 8-bit integer is 0xff. So yeah, that'll give it 255. And the reason why we're initializing the depth buffer at 255 is because every time it draws a pixel, it's going to compare the depth of that new pixel to the depth value saved in this buffer. And then if it's less than it, then it draws the pixel. Otherwise it doesn't. And that way you don't have things overlapping each other unnecessarily. And we're going to be able to calculate the depth as well, but just that's going to be something for a later tutorial. So now we're going to want the ability to, we are going to need the ability to set individual pixels. So void set pixel. The way I want this to work is you to be able to pass in a int x, int y for the pixel target, and then we want a color buffer t pixel color, and then a depth buffer t depth. So then to implement this function, let's go down here, we're going to go ahead and say if the depth is less than, well, first let's go ahead and calculate an index. So int index is going to be equal to x times width plus, well actually it's y times width, excuse me on that one, y times width plus x. And the way that that works is if you think of the screen as going up and down, which it is, for every y value it needs to skip the width number of pixels, because it would have to go from one side of the screen to the other. So if it starts at 0 and then the width is 10, it'll need to go down 10 to get to this element, because it would go from 0 to 9 on the first row, and then 10 would be the next element. So whatever the height is times the width with the offset of x will get you that. And the same works if it's a y of 0 and x of 4. It would just go down to 0, start at 0, and then count over 4, and you have that same exact correct pixel. So that's how we calculate the index. So let's just do a quick comparison. If depth buffer subindex is less, well, is greater than, well actually let's do it like this. If depth is less than, or not or equal to, only if it's less than depth buffer subindex, what we're going to do is, if that is the case, then we're going to write the pixel. So then we'll just say color buffer sub index is equal to pixel color. And then the otherwise condition, we don't actually do anything, but now we actually say depth buffer subindex is equal to depth. See how that works? You set the pixel and then you set the depth after comparing to see if it should be set or not. And that is actually going to be it for that function. So now let's go ahead and have a quick function to get some things here. So back to here. Whoops. Int, well actually color buffer t get color. You give it an int x, int y, and then also a depth buffer t get depth, int x, int y. And then copy those, paste them in here. Alright, so to get the color, once again we calculate the index in the same way. But now we just go ahead and return color buffer sub index. And then here we return depth buffer sub index. Let's go ahead and make sure there are no errors. There are errors. Width was not declared in the scope. I'm guessing I did not set the... Yeah, I did not do this. Kind of a difficult thing to remember when using C++. And I called that debug buffer, when this should be depth buffer. So yeah, now that compiles. Let's see what else we want here. Let's go ahead and have a pointer to get the color and depth buffer as an array. Actually, for the sake of encapsulation, let's leave that alone. Yeah, finally, we just need the ability to print the frame buffer onto the screen. So, void print, we're going to have a starting location and we're just going to print it to the screen based on an offset. So we'll have int offset x, int offset y. And those offset variables will just be so that it can say, okay, I want to move over to the 1010 pixel, and it'll come down here and then start rendering the frame buffer from this pixel to the width on this end. Print's going to be a real simple function. So void frame buffer print. All we have to do here is say for int I equals 0, I is less than, well, actually I is equal to offset x, I is less than width. Actually, let's go ahead and do offset y, and I is less than height. Whoops. And then do the for loop again, but on the inside, and with j as the loop variable, but with offset x, and then looping through the width, and then j++. So you just loop through each pixel in the frame buffer, and then we actually render it to the screen using print w with the j comma I, because you have to remember j comes before the I in the print w, well, mv print w function. And then we give it %c to tell it that we want a char. And then we just go ahead and cast the color buffer sub I. Well, the index is going to once again be width times j plus I. And then we give it the index there. And then print it into that. So if we remember, the character to print would actually be the first element of the color buffer. And then we're also going to need one other thing here. So int color is equal to color buffer sub index shifted over by 8, shifted right by 8. And then we can go ahead and, for good measure, cast that to a char. So the way colors work is you'd need to do something like atron, and then color pair color. But colors won't actually work for us yet because there needs to be some initialization done in the main file, but we don't really need to worry about that just yet. Let's just have this small set of code here. Another thing I'd like to do is, instead of rendering it directly, I'd like to do int character is equal to color buffer sub index casted to a char. And then I'd like to go ahead and do a test here where I go, actually that's not how I'm going to do it. Instead I'll just do if color buffer sub index, if it's equal to 0, continue, because if there's no pixel to render at that point, there's no reason to do that. So yeah, if the color is 0, then don't bother. And then that should actually be everything we need for this. Let's go ahead and clean this up just a bit. There we go. And then before we can actually see the effects of this code, we're going to have to make some very small changes in our main file. So go to main.cpp, and then the way we're rendering this is we're calling rasterize triangle. So let's see, if we make run, it'll still render. So in our rasterizer, instead of doing mv print w, we're going to have to, so if we open up the rasterizer, we have a frame buffer pointer here. We're going to need to instead say fb set pixel, and then we're going to need to pass in the values. So in this case, it's going to be I, j, because that's the x and y location of the pixel. And then our arguments for this were x, y, and then the color pixel is this, but we're just going to give it a depth of 0 for now. And the pixel color is just going to be the character to print, because, yeah. So we give it the hashtag and then a depth value of 0. And then for this one, we give it the dot with a value of 0. And now if we run this, you'll notice some bad stuff will happen because, well, this of course needs to be a const char instead of a const char pointer. And then we of course need a comma after this. And there we go. So now nothing prints onto the screen, but that's okay because we're going to fix that. Let's go ahead and add one quick method here. Inline void PresentFrame. And actually, we can make one small change here, can't we? Because I'd really like for this class to handle double buffering as well. So the rasterizer is going to have to be a multi-purpose class, which is kind of a cardinal sin of programming, but I think it'll take more time than I'd like to go ahead and reformat this. So we're actually going to have this class handle everything to do with the frame buffers as well as rasterizing. Object-oriented programming is easy. Yeah, no. But we're going to have PresentFrame, and then we can just give it this. And in this PresentFrame, we can give it int width, int x, int y to give it the offset, and then void rasterizer PresentFrame int x and y. And then instead we're just going to call fb print x, y. So it's just a quick wrapper here, but I obviously made it inline, so that was a bad idea. So yeah, just fix it there. And now into main.cpp, what I'll do here is instead of, well, after calling rasterize triangle, all I need to do is call rasterizer, dot present frame, and then give it 0, 0. But let's make sure we have everything going here. So it's getting the width and height, and then in the constructor it is, in the constructor it's creating the frame buffer with the width and height, and then in the constructor here we are creating this here. So in the constructor we're calling recreate. Okay, we're good on that. And we have our print function, which should be good. Yep. So all we need to do here is just go ahead and do that. And now that we're calling PresentFrame, this should actually just work. And we have a segment fault. Okay, that's cool. We'll correct it with that program, and let's go ahead and see what the segment fault should have been caused by. My presumption is that, well, because it did not occur, it occurred on the PresentFrame. Yeah, so PresentFrame segment faulted. Let's go ahead and see what the problem with that is. because that would happen on print. We're going from I to j. Well, I is looping from the height. We need this to be width and this to be height. So now in main, we're still calling PresentFrame, but nothing is occurring here. Let's go ahead and make sure this is all working properly by calling mb print w. And if it ever gets there, okay, it does get there. But after this continue, does it ever get there? No, it does not. So every value is being set to null in the rasterizer. So that means it's never... depth is never less than the index because we did not call clear. So after PresentFrame, we need to have rasterizer.clearFrame. That's something I forgot about. My bad there. Just create that little inline function here and then just make it call fb clear. No function for framebuffer.clear, are you sure? Because I thought I created that. Okay, we need the clear color and we'll just give it 0 for now. So after clearing that, that should have worked, but it did not. Alright, so the problem was actually very simple. After about a minute of debugging, I realized I'm calling this clearFrame function before I call after I call rasterized triangle. That would be a problem, because the thing is, rasterized triangle, that's the function where it checks the depth values. So if I run it like this, you'll notice it will definitely not work, because every time it checks the depth value, it's not less than it. So to fix that, put the clear frame above rasterized triangle, and then it will work. There you go. You'll see the triangle is able to render onto the screen. And with that, I believe that actually concludes this tutorial on frame buffers. So I hope you enjoyed, maybe you learned something, and I'll see you all next time.